Good morning, guys. Welcome to 13.3. In this video, we're going to be talking about acids and bases in just a little bit more depth. So, if you guys remember from our definitions not yesterday, but in our first video, we learned about Arrhenius acids and bases. Arrhenius. I never know if I'm spelling it right, so I think I'm spelling it right. And we said Arrhenius acids are going to be acids that produce that H plus ion in water, which means they have to have an H plus ion in their formula, right? And then bases, we said that they produce OH minus ions in water, which means they have to have that OH minus in their formula. So right now I'm just going to be talking about Arrhenius acids and bases. All the ones that we're going to look at least in this video, are going to be Arrhenius. So here is a table, and I'd like you to copy it onto your notes. It's a table of the common strong acids and common strong bases. For our purposes, this is going to be a comprehensive list, meaning that everything on this list is strong, and anything that is an acid or a base, but that's not listed on this list, is we are going to consider weak acids or weak bases, okay? So again, if it's not on this list, then we're going to consider that it's a weak acid or a weak base. So let's just take a look at the list of strong acids. These right here are three binary strong acids. And the way I remember them, and by the way, you don't have to memorize these, but it is convenient to have them memorized. But the way I remember these is I think of the word Brickle, and Brickle is just Br, I, and Cl put together. So Brickle are the three binary strong acids, and then there's four strong ternary acids, and these are ones. Remember, ternary is just any acid that has three or more elements in it, and that is sulfuric acid, nitric acid, perchloric acid, which, by the way, this compound is called perchlorate, which is why the acid is named perchloric, and this is chlorate without the per in front of it, and that's why it's named chloric acid. Over here on the bases, we kind of have two groups. Anything that's part of the alkali metals, that's anything in group 1. Anytime anything in group 1 pairs with a hydroxide, those are going to be strong bases, okay? Anything in group 2A, as long as it's calcium, strontium, or barium, so that's really not anything, those three elements in group 2, those are called the alkaline earth metals. Those, when they pair with hydroxides, they are also considered strong bases. But remember, that's not anything in group 2, okay? It's just a few select ones. And then really anything in group 1 pairing with hydroxide is also a strong base. So now we're going to talk a little bit about this, like what makes an acid or a base strong versus what makes an acid and base weak.
Okay, so now I want to talk a little bit about what makes something strong versus what makes something weak. So we have a list of strong acids and strong bases, but what makes something a strong acid or a weak acid and a strong base or a weak base? It actually has to go back to something we learned about in our previous unit. We talked about electrolytes, right? There's two types of, hold on, let me get my pen. And we talked about how electrolytes break down into two main categories, strong electrolytes and weak electrolytes. And strong electrolytes, which, by the way, since acids and bases are all strong electrolytes, when I'm talking about strong electrolytes, I'm really talking about strong acids and strong bases. Here's a good definition of what happens to a strong acid or base when it gets into water. It completely dissociates into ions. That's really important. Dissociates completely into ions. And we can see here that we had HCl as a compound, as a molecule beforehand, but then when it went in water, I see that it's broken down into its ions completely. Okay, I don't see any HCl in the liquid, what that means is that this acid is stronger because look how many H plus ions are dissolved in water. There's a high concentration of ions, okay? For an acid, that would mean it's a high concentration of H plus ions. For a base, we're talking about having a high concentration of OH ions, okay? Now, the weak acids and the weak bases, here's a good definition. It just says that they did not completely dissociate in water, which means that there's some ions and then there's some molecules. So here we have some ions, okay, and then some molecules. Some ions and some molecules. And if you look here, we have fewer H+ ions in solution than we had in the strong. And that's because a lot of them, the H's, are still with their compound. So here we have a lower concentration of ions. And this, again, this picture shows a weak acid, but this picture also can be used to show what happens when weak bases go in water, except instead of having low concentration of H+ ions, they're going to have low concentration of OH ions, okay? So my strong picture is on the left and my weak picture is on the right. Last thing I want to talk about today, this is kind of a shorter video, I want to talk about indicators, pH indicators. So we talked about the pH scale just very, very briefly, and I mentioned how the pH scale, basically the pH scale just tells us the concentration of H+ ions. So it tells me if something is an acid or if something is a base. And so what I have to indicate the pH of different substances, to indicate if a substance is an acid or a base, are these indicators. Okay? Red litmus paper is used to detect bases. If you take a red litmus paper and you put it in a base, it will turn blue. If it turns blue, it is a base. Okay, so the way I remember that is BB. Blue equals base. If it turned blue, it's a base. Now, litmus paper also comes in a different color. It comes in a blue color. Okay, but if that blue color, if you put that in, and this is designed to detect acids, okay. My pen is being really bad. I'm so sorry, my handwriting's hard. My pen is just not working very well today. So the blue litmus paper is designed to detect acids. If the blue litmus paper turns red, then it's considered an acid, okay? So red goes to the acid. If it turns red, it's an acid. If it turns blue, it's a base. Red cabbage juice, I'm going to say see photo for that. This is the indicator for red cabbage. Red cabbage looks red, and when you soak it in different substances, it can turn different colors. If it turns yellow, then it's considered a base. If it turns this pink color, then it's considered an acid. And the last indicator I want to talk about is phenolphthalein. You can put phenolphthalein inside of a substance, and if it turns slightly pink or bright pink, it's going to be considered a base. But when it's colorless, it's considered an acid. So really, we use phenolphthalein when we're trying to bring an acid closer to neutral. So we'll put phenolphthalein in an acid and it'll be colorless. But then when we add a base to it, drop by drop by drop, it slowly is going to turn more pink. And that's when we know we're bringing it back to neutral. We're bringing it from the acid side to the base side. And that is it for our 13.3 video. Y'all have a fantastic day.